Hey everybody, welcome back to my YouTube channel and the ongoing series of Workshop Quick Takes, WQT. Last time in this series, we looked at 3 classes of household appliances that had failed. Took them apart, kind of looked at the insides, determined there wasn't much we could do for them, but hey, it was kind of neat to see what was in there. Today, we've got 2 more types of appliances, except this time we decided they were repairable. So we're going to take a look at those real quick. And to reiterate our disclaimer, we're going to be working on equipment that is powered from the mains. In our case, it's 120 volt here in the United States. Depending on where you are, it may or may not be permissible for you to work on consumer appliances that are powered from mains. So make sure you know your laws, make sure you know your skill set. We've got an electric hot pot or kettle, and we've got an overhead LED light fixture. We're going to take them apart, try and figure out exactly how they work, figure out where they failed, and then correct it. So come along for the ride. Okay, this here is a hot pot, 120 volt of course, because we're in the United States. And I pretty well burned this thing down running my French press. But this one here, you put it on and it starts to warm up, starts to boil, then it cuts out. And then it comes back on, cuts out. But it's not this. This is still on. And so I began to suspect that maybe there were some overheat switches in there that had gotten weakened with age. So we need to start by getting 3 screws open on the bottom side here. You can see that this does use one of those 3-pronged security bits. It's kind of like a Phillips head, but with 3 rather than 4. And I think I have one here that'll do it. This one maybe? Want to guess where you can get a nice set of security bits if you don't have one already? This one did not come from Harbor Freight, but it could have. One thing we'll want to be careful of as we pull this base apart is whether or not any of this hardware is attached to it. And in particular, you notice that there's a little indicator light here that might be. So we don't want to just yank it off or let it fall off. And these little electric pots, even though there's not a lot to them, in theory, still cost about 40 bucks. So if the only thing wrong with this one is the little overheat switches, I'd rather try and repair them. Okay, so yeah. Got a couple wires here to a light that, oh, just pops out, a little neon lamp. And then this just slides off the switch. Cool. Alright, so how's our construction go here? We've got our lever here. It appears to be operating a pair of contacts there and there. The light is tied in, looks like on the downstream side of the contacts, which makes sense, so that when these are closed in, then the light comes on. And then, of course, we have our coil here. Heats up the water. And it almost looks like it's cast into this base plate somehow, and then, I don't know, soldered on? In any case, to get that off, it looks like we have 3 more Phillips screws to loosen. Yeah, that one's not big enough. And it looks like these are machine thread screws with captive lock washers, which is good because you don't want any of this assembly coming loose on its own in there. Okay, so now we're loose except for the connections to the heating element. There's a couple like tab terminals or something going on here, which makes sense because these have to be welded to the actual elements themselves with a little bit of a distance to keep them from overheating these contacts back here. Let's see if we can work those loose. Let's try using a flathead screwdriver to prise them off a little more gently. There we go. This one here. One thing I'm not entirely sure about is there appears to be a little bit of some kind of welding or heat damage right there on that tab, and I'm not sure why that would be, unless that just happens to be the one coming in on the line side perhaps. And it looks like I might have loosened that tab up slightly, taking it apart. That's one of the first things I want to try and fix if I can. Oh yeah, there we go. Yeah, that's better. Because yeah, if that's loose at all, then it's not going to make good contact up here. Just to make sure I'm getting a good connection. Okay. We have power coming in on the center pin and this sleeve right here. And then this outer sleeve is not connected to anything. And these are then feeding a mechanism which includes this latch, which has a spring clip. But the problem is there's a safety on it. You see that little red thing popping up and down right in there? That's a safety to make sure the pot is set on top of the base. So if I push down that safety, I can latch it in, but as soon as I let go of that, it pops out again. So that's the first mechanism to ensure that this pot is kept safe. If you lift it off, it's going to release the mechanism. Next thing we can look at here is there's a steam tube coming down, and that comes to right here. And once this thing starts boiling at a high enough rate, the steam pressure on here, the heat and pressure coming down in here, will cause a bimetallic trip plate to warp in there, and then that's the next way this can be released. And I don't want to stick anything down in there just in case I mess it up, but that's the mechanism of it, because if you open the lid on one of these, it'll just keep boiling because the pressure doesn't build up in that tube coming back down and heat up that plate. The third thing I see going on here, which I think was the source of our problem, is these two strips with the heatsink compound on them. Kind of dried out, so I'll probably clean and reapply that. I see two little white mechanisms down in there, and I think what happens is, let's find out. If I reach down in here and push on one of those, yeah, look at that. It will open the tab even though it doesn't trip the mechanism. So if either of these tabs gets too hot underneath here, like for example, if you were trying to run this dry, then those will open up the tabs here and keep disconnecting power in order to regulate the temperature. So it's crude but effective, and the one thing that surprises me a little bit is I do not see any one-time thermal fuse in here. Usually you find those in like coffee makers and espresso machines that have an internal heating tank, but maybe because this is external and it's a removable appliance, the code doesn't require that. I don't know, but it's not in here. Those are your mechanisms. You have a mechanical interlock right here for when you lift the pot off of the base. That'll release the lever. You have the boiling point exceeded thing here, so that once it's going at a rolling boil, the heat will release the mechanism again mechanically. But then you also have these two safety contacts. Roughly here and here is where they're making contact with the pot, so that if the base is heating up too far, which would happen if you were trying to boil it dry, then it will keep disconnecting the power to try and avoid an overheat. Interesting. Just need to tweak these tabs up a little bit. I suspect that over time they've just become weak, and if I tweak them up a bit, that'll give them a little bit more springiness so that they don't cut in and out too aggressively like they were doing. And the other thing I want to do, just to make sure my contacts are making good contact, is tweak this down slightly. Now right now I should be able to see them in there. They should still be open, and they are. But that'll give them a little bit of a tighter interface to ensure that they're making good contact all the way through the circuit to run the heating element. Okay, now that I've tweaked everything, I can put it away. And one thing I can do to check this real quick before I reassemble anything, I'm going to go ahead and take a meter, and I'm going to set it on a fairly low resistance test, because this thing's probably not going to be more than, like about 25 ohms maybe. I mean, we're at 120 volts and we want to put a lot of power through it, so let's see what that comes out to. 10 ohms? Yep. Okay. So these are all adjusted. Everything's still in good working order. Got these brackets tightened down just a little bit. Hopefully everything goes back together, which means I just need to get a little bit of thermal paste back onto these overheat switches. I cleaned them up. We'll just put some fresh compound on since they were pretty dried out. And it looks like my light's still nice and clipped in. Before connecting anything, let me just double check the impedance of my coil. Okay, 10 ohms. Go ahead and connect all this up. This is going to be tricky because I've got to somehow reconnect both of these. Alright, there we go. And work them on gently. Alright, let's try and get this back together and see what happens. Cinch that down but not actually torque it yet until I have the other two in place, make sure everything lines up. Need to be a little careful. I believe these are aluminum screws, which is good. I am going into cast aluminum base here, so in the event that these screws are something other than aluminum, they could really tear up the threads in there, but I think we're okay. That's two. That's three, and I'm going to go ahead and cinch these down now. 1, 2, 3. Still operates freely, and now I am going to take my 2 meter terminals and see if I still get a stable 10.6 ohms, 10.4 ohms, 10.3 ohms. Good. Almost no contact resistance. And I'm measuring the same coil that I measured open. So the last step is to try and get this put back together. Now it's going to go like that away. The light's over here. So I just need to tuck that down in there, nice and tidy. Thread that over, make sure nothing is pinching or binding. Looks like we're good. And put in the last 3 screws. We should be good to go. And these I don't have to torque excessively because it is into plastic. Alright, last check. Put some water in it and find out what happens. It works. For now, anyway. Okay, here we have one of the individual lights from that fixture. The way these work is, first of all, I got to remove this, and then I've also got to open up this. The way this particular track light assembly operates is there's a couple tabs here, and on that track, these 2 copper terminals push into those grooves and make contact with the power rails inside that plastic strip. The top of that plastic strip then has a ground line on it, and that's what this contacts to. So all the metal parts on this get grounded back through the J-box, while power is fed into the light through these 2 terminals. But let's go ahead and pull this apart. Get the glass off there. Construction here is pretty typical for one of these LED lights. We have this little plastic diffuser over here, but I see just a little LED panel down under there. And there's 4 Phillips screws to get at it, so let's get this part popped off and see if we can figure out what's going wrong with the ballast. Okay, so it looks like those 2 were holding on the plastic diffuser. There's the actual LED element. Interesting. Well, this was a properly UL listed device sold at, I think I got this from Lowe's, so I'm not surprised it has a proper ballast in it as compared to some of the cheap Chinese knockoffs that you take apart and there's just a little board in there with maybe some potting compound. But this shouldn't be too difficult to deal with. We just need to pop this little lid off and then we ought to be able to take a look at the ballast. Well, there we are. It's a fairly nice little switcher module. No obvious damage to speak of. There's no discoloration, no parts blown open or darkened. I don't know why this would have quit. The only thing I don't like is that there should not be bent over like that. But maybe that happened when I was pulling it out. Oh, wait a minute, I lied. Well, it's ruined now. Looks like I damaged a C5, a small surface mount capacitor there when I was pulling it out. So we may never know why this is dead, but I'll have to go to the manufacturer and see if I can order a replacement unit. I'll probably have to buy this whole thing in order to repair the fixture, but okay, let's take a look and see if the LED panel that we pulled out of that light is actually the problem. Now, I have here a power supply that's capable of plus and minus 25 volts. The ballast that went on this talked about being 33 volts at 150 milliamps. Okay, so even though it's red, black, red, that's because the center is common. This is plus, and that is minus. Let's go ahead, pull out the handy dandy meter, set it to DC volts, and just make sure than I'm actually seeing on my outputs what I think I'm seeing. Output on, plus 25 volt, currently at 0, so that's fine. But I'm going to start way down here at plus or minus 5. So now I need the minus 25 volt source. Go ahead and turn that up to 5. And if everything is working the way it should be, okay, good. I have 10 volts. Output off, and connect my leads. The other thing this meter will very nicely display for me is DC current. Output on. So I'm putting 10 volts across that panel and getting effectively nothing. So let's go ahead and raise positive voltage, negative voltage. I'm now putting plus or minus 10 across it. So 20 volts across the panel, still nothing. Bump it up further. So now I'm at 28, not getting any illumination. Minus 15, plus 15. Kind of suspecting it's dead. I really think I should be seeing it turn on by now, but I'm not even getting any current across it. It suggests an open circuit. Well, there you have it. I mean, we opened the ballast and looked at that and didn't see anything wrong. Now we're putting plus 16 and minus 16 across the panel and not getting even a faint glimmer out of it, and there's no current being measured across the load. So that's a pretty good sign that it is in fact dead. It went completely open circuit. Okay, let's try and see if we can break off any of this. There's a good start. Well, down there is potentially where the LED dies are. We're not going to be able to see much more than that. There is an array of 3 by 4 LEDs on there. That's 12 total. That explains why our ballast was showing a output voltage between 33 and 40 volts, because these are blue LED dyes normally, and then there's a phosphor layer with possibly some tinting on top in order to create the white LED output and then maybe change its color temperature. But each of those blue LED dyes then has a forward voltage around 3 to 3.3 volts in which it will operate. And in this case, we can assume they're all connected in series, because 12 dyes at 3 volts is 36, and then you add the additional 0.3 and you're hovering right around 40 or so to drive them. However, because they are connected in series, there's another problem that can come up. If one of them starts to fail, then what usually happens is it burns out, but then the voltage tries to arc across the die because there's a semiconductor layer on the bottom of it. And then it'll sometimes arc across, maybe sustain for a bit, fall back off again, and that's why LEDs often flicker and flash when they're nearing the end of life. It's because they're usually a collection of multiple dyes like this, and when one goes bad, then it starts to break the circuit. This is a GU10 style LED bulb that replaces a halogen 1-to-1. This is a particularly good quality one by Philips. It turns on instantly, it responds very nicely to dimmer switches, which not all of them do. Here's what particularly bothers me about this design now that I've had it apart. This here outputs at least as much light as what this did, and it did it with the entire ballast in a compact package like this. I've had some of these running day in, day out for a couple years with no issues at all, and this here blows up. But this is my idea for trying to repair this fixture, is something like this. Here's the next challenge, however. The depth of the bulb, even if I make some sort of accommodations to get it a little above, yeah, it's going to be hard to get that in there with a GU10 socket. Speaking of, I ordered some off of eBay. Here's a 10-pack of ceramic sockets and silicone wires. So down in here, there's plenty of wire lead length to come all the way back to here, so I can completely replace the wires in here and just reuse that high temperature protective sleeve there. But the problem again is, once you have this bulb on here, how's it going to fit? So that brought me to my next idea, which is this. This is another type of form factor that uses a GU10 base, but you can see the difference in size. So let's get this out of the package and see how that lines up for us. I'm not sure exactly how this will compare in terms of raw light output to this, because these only come up to a maximum of a 35 watt halogen equivalent. But there we go. And if I put it in the socket, that's looking more doable. The other thing I like about this is, with just almost no modification whatsoever, I might be able to get into the plastic base there. Yeah, in fact, look at that. I'm not sure how well that's going to work once I clip it into the glass here. Oh, look at that. Now that's perfect, because once it's clipped into the glass like that, the little slot tabs sort of lock everything into place. So literally all I have to do is get these wire leads put back in, and I think we're home free. Let's fire this up and just see if it's putting out light the way I want it to. Don't do this kind of work unless you are already comfortable working with 120 volt circuits and know how to do it safely. I'm not going to be able to show you everything I'm doing to keep myself safe. It's also possible I'm doing something here that you shouldn't do. One thing I am doing to protect myself, though, is my workbench here has a row of ground fault outlets. It's supposed to by code, because we're in a basement area, which is considered a wet space. However, I'm just going to briefly plug in the cord and see if that light comes on and how bright it looks. Okay. I don't think that's going to be as bright as the original, but compared to having nothing at all up there, it'll probably work. So there we go. Just have to do a little wiring work down into the connector up here, and at least I'll have something rather than nothing. The always popular Christmas tree bit or stepper bit was used to drill this hole out to be just slightly larger than this. The original LED was mounted on this plate as a heatsink. I blew out the middle, and the reason for that is simple. When we get this lined up correctly, we now have two mounting holes that mount this plate to this plastic acrylic piece which holds the glass, and then this plate physically mounts in here. So let's start with our two remaining machine screws here. At this point, we are reusing all of the original mounting hardware that finished assembling this together. Difference is, instead of having the old ballast crammed down inside this thing, we are now going to have our socket, which should just tuck down in there nicely. There's no real sharp pieces of metal down there to interfere with it. And of course, it attaches very nicely to the base, so I don't expect any loose connections there. So the final step is just to get that down in there and start these two sets of screws, attach our glass, check for continuity errors, and then hopefully we're home free. Okay, that should be it. Last step, of course, then, is to check for continuity errors. If the socket works loose from the light down in there, that should not create a short circuit. It should just fall down in there and that light will go out. But I do want to make sure I don't have any connections I shouldn't have between earth, or that being the whole metal chassis, and either of these tabs. And I shouldn't be able to detect much of anything between these two tabs either. Nope. And if I reassemble this correctly, these should have some springiness to them. And well, they do a little bit. There we go. Okay, we're good. Ideally, this is ready to reassemble. It works. For now, anyway. Hey everybody, thanks for joining us today on Workshop Quick Takes. Hope you found that interesting. Kind of show the limits of what is and isn't doable within modern appliances and electric equipment. Stick around. We'll be doing this off and on again as time permits. Hope to see you again next time. Has anyone seen my phone? Oh, there it is.